All right, so this is part 2 of the video for the lecture on reliability and validity for CDV 320. So we talked about validity in the last lecture or last video. Validity, again, is what we're sure that we're actually measuring what we want to be measuring, right? That we're actually measuring the real thing. And that whatever we're measuring is going to have some bearing on the real world. Reliability is how often we can actually get the right answer, right? How often, let me say that a different way, how often we can all agree on the same answer, right? So something can be very unreliable, and it can be it can be pretty unreliable but valid, and it can also be very valid without, or very reliable without good validity. So we can think about reliability as the center of a bullseye, as in this picture. So on the far, let's see, right of your screen, where all of the little dots are in the very center of that bullseye, that's what we're looking for. Something that is reliable, so all of the dots are very close together, so all of the hits are very close, right? And it is in the center of the focus of what we're looking for, right? So that is the goal. We can also be very reliable. I agree that Gouda is cheese. My sister agrees that Gouda is cheese. My mom agrees that Gouda is cheese, but whether or not Gouda is cheese has very little to do with whether it tastes good, right? We can all agree, we have very good reliability. That is cheese, right? Whether or not it tastes good is, right? We can, that's an individual thing. It totally tastes good, but we can disagree on that, right? The thing is that if something's really unreliable, if we can't all even agree that the color of this fabric is blue, then if we're trying to use this to blue as a way of indicating that if somebody's lips are blue, so they're not getting enough oxygen, if we can't agree that blue is blue, then we're really not going to be doing a very good job of diagnosing somebody needing more oxygen because their lips are blue, right? So it becomes not a good measure in terms of validity. It's not actually measuring something correctly in the world if we can't all agree that it is actually measuring what we think it's measuring. Hopefully that makes sense. Ask me questions if it doesn't. So the goal here with reliability is how close together are our measures? How similar are our assessments of a given thing? That's what reliable is. For example, my scale in my house could weigh me. I actually had this happen a couple of years ago. So my scale weighed me at 130 pounds. 130 pounds, 130 pounds, 130 pounds. Every time I weighed myself, I was 130 pounds. I went to the doctors and I was 140 pounds. So my scale was really reliable. And if we argue that the scale in a doctor's office is probably more accountable, we believe it better than the one at my house, my scale was reliable over and over and over and over and over and over and over again. It gave me the same reading. When I went to the doctor, I found out it wasn't valid, right? So it wasn't bearing on reality. Okay, so reliability we can also talk about as consistency or validity or stability. Okay, so it's, reliability is important because otherwise if we measure somebody with a survey today and then measure them with the same survey tomorrow and they get something totally different both times, then how much do we believe what that survey said, right? If it's that changeable, what good is it, right? We want things to yield the same information as much as possible. There is some amount of the time that things won't yield the same information, and we call that amount of time measurement error. We want to minimize measurement error. So reliability, we want any score that we take is going to measure whatever is the true score that we can't actually ever get at because we're just guessing at whatever my real weight is, whether it's 130 or 140. So whatever measurement I'm getting is whatever I really truly weigh. I don't know, maybe we ask NASA or somebody what the real true one weight is. And then some measurement error because my scale's probably wrong and the doctors might be a little off too. So how do we increase reliability? So for reliability, on a survey, we can use multiple items to get the same thing. You may have noticed in surveys you've taken before, these could be surveys that you've taken for fun, surveys that you've taken for other classes, that there are lots of questions that ask about the same kinds of things from different kind of angles, right? Do you consider yourself a happy person? Most days. Do you find that you have a positive attitude? Most days, are you wearing a smile, right? Kind of asking about the same thing, right? We can also use very careful measurement procedures. So be very specific about how we go about measuring. So we're making sure that we're doing the exact same thing for every participant, exact same thing for every observation. This is really good for you guys to think about as we're going into coding data later in this class, because you will need to think about being very specific about your instructions for how you're going to code, because that is our measurement, right? And if we're all kind of going about our coding in really different ways, then the likelihood that we all see things the same when we're trying to assess them is low. So very careful measurement. For surveys, we also want to be really careful about how we phrase things. So the words that we use. There's a great study, I don't believe I've assigned it for this class, that suggests that if you tell kids that they are, if you thank kids for helping, thank you for helping to clean up. That is less motivational and they're less likely to help more in the future than if you tell them they are a helper. Wow, that's so great. You are a helper, right? So the phrasing, even that little tiny bit of a phrasing change, even for, I think the study was originally done with preschoolers, even for preschoolers makes a difference. Okay. So we can also look at internal consistency within a survey, within a scale or a measure. This is ways of kind of testing a measure when you're putting a measure together. There is a lot that goes in to putting together a working survey. We're going to construct one as part of this class later, but there's a lot that goes into making one that you're going to publish and that you're going to try to put out there. Ours is not going to be as complex as the ones that you can find out in the world. So our conceptual model here is that for internal consistency is that we have several things that we're trying to get out, underlying topics, and then we have lots of different questions that try to get at that. So what we would do for internal consistency is we're looking to see how well those different questions that we are using to try to get at the same concept kind of hang together. How similar are people answering, right, who are taking our survey, answering all the questions that are on the same topic. Let me give you an example. Let's say that I'm doing a survey on how faithful people are in their romantic relationships, right? How likely they are to cheat. And if I have a bunch of questions about whether they flirt with other people besides the person that they're dating, let's say I have 5 different ways of asking about that topic. Well, you want people who are really big flirters to answer those 5 questions all similarly, right? You want folks who are not big flirters to answer all of those questions similarly in the other direction. So what we would do is try to give our survey, kind of test it out, pilot it with a bunch of people and see if all of the folks who have a given set of behaviors are answering about those things in about the same way. One of the metrics that we use to measure this is Chromebox Alpha. I am not going to ask us to calculate this in this class. Is something that you can do rather easily on SPSS, but this is one of the things that you would need to report about a survey that you use. So if I give the Beck Depression Inventory, which is a commonly used measurement of depression, I would need to report what this inventory usually gets as a Chromebox Alpha, because that tells us how internally consistent it is. So things might be low in internal consistency if those factors or those concepts like flirting are not real clear in how I have imagined them or how I have asked about them in the questions that I've chosen. So a couple other types of reliability. Test, retest. So if we're looking again at a survey, we can check out reliability by giving someone the same test at 2 different points in time. We can also do this with other kinds of tests. So tests for performance versus ability. So if you give me a test of running today and a test of running tomorrow, you could look at the difference between those 2 days to see whether I was just having a good day or a bad day, or whether how good I actually am at the skill or at this behavior. We can also use split half, and this is where you give someone 1/2 of a survey and then compare their performance on that half to the other half. Inter-rater reliability, and this is important for the coding that we will be doing in this class. Inter-rater reliability is when you have multiple people look at the same thing and try to come up with the same assessment of it. So again, we're going to tell these people very specifically, this is what you're looking at, right? Look at this behavior, look at this, look for people clapping, count how many times they clap every minute or every 30 seconds or whatever. And then you try to get multiple people to look at the same event, count it, and get the same number of claps, right? If you go to the activity for this week, I have an activity that looks like this for you guys to try. So you would look at the agreement across raters on that activity. You can measure this or report this as the % agreement, a correlation between the scores or the counts of 2 different raters, two different people looking at the same data, or a kappa. Okay, so when we're thinking about coding, and this is going into some of the stuff we will be doing with coding later in the class, you need to be very careful as we are looking at trying to conserve reliability and be specific enough to get our validity right. You need to look at what is your objective? What are you trying to code for? It has to be observable, it has to be simple, it's got to be something that objectively multiple people can see, right? That's why we don't typically code for intent. I can't guess what you meant to do. I can only look at and report what you did do, right? Unit of analysis, we would have to describe or decide how many times we're counting. So in the example that I just gave you of counting how many claps per minute, the unit of analysis is the minute. You can also do a unit of analysis as the event. So how many times did the people clap after this statement in this speech? How many times did they clap after that statement in the speech? So looking at different responses to different stimuli or different events. Right? All right, so that is the last we've got here. So again, validity is, am I testing what I think I'm trying to test, right? Is my operational definition really getting at what I want it to get at, right? Am I really looking at what I think I'm looking at? Reliability is, if I give everybody this description of this observational definition, are we all going to see the same thing? If I test you today and I test you tomorrow, am I going to get the same results, right? So reliability is, can I get it over and over and over again? Validity is the measure anything like the thing I'm trying to measure like reality? Okay. If you have any questions, let me know. We're going to work with some of these concepts later in this course.